All right, let's jump into a deep dive, shall we? Today, we're exploring those spots on Earth that really make you appreciate just how comfy and livable our part of the planet is.
Yeah, those places that push the limits, the uninhabitable zones.
Exactly. Places so harsh you wonder how anything could survive there.
Like a window into the raw power of nature. The extremes.
Absolutely. And we'll be using an article as our guide today. It's called Top 10 Most Uninhabitable Places on the Surface of the Earth. Pretty straightforward title.
It gets right to the point.
It does. So buckle up, because we're about to explore some of the wildest environments on Earth.
Let's dive there.
First stop, the Danakil Depression, located in Ethiopia. It's often called the most dangerous place on Earth. And honestly, just looking at pictures is intense. We're talking temperatures over 113 degrees Fahrenheit, boiling hot springs, and poisonous gases just spewing out of the ground.
Yeah, the Danakil Depression is a fascinating case, geologically speaking. It sits in the Afar Triangle where three tectonic plates are pulling apart.
So the ground is literally splitting open there.
Essentially, yes. And that's what drives all the volcanic activity, the hot springs, the toxic gases. It's a super active geological zone. And with the low elevation and lack of any plant life, it gets insanely hot.
It's mind-boggling to think anything could survive there. And speaking of extremes, let's jump from the scorching Danakil Depression to the icy plains of Antarctica in the North Pole. We all know they're freezing, but did you know Antarctica is actually the driest place in the world?
It's true. And it all comes down to how air circulates globally. Cold air can't hold as much moisture as warm air.
Right.
So as air moves from warmer areas toward the poles, it gets colder and dumps most of its moisture as rain or snow. By the time it reaches Antarctica, it's bone dry.
Wow, so it's like a giant cosmic dehumidifier sucking the moisture out as it goes south.
Oh, that's a great way to put it. And because it's so cold, any moisture left just freezes, making snowfall even less likely.
It's wild how these seemingly simple processes create such extreme conditions. But what about the people who work in Antarctica, like researchers? How do they survive in such a harsh environment?
They rely entirely on tech and supplies brought in from the outside. Specialized clothing for the cold, shelters to protect them from the elements, and of course a constant supply of food and water.
It really highlights just how hostile these environments can be, even with our best technology. All right, let's shift gears now and talk about a place made uninhabitable not by nature, but by human actions. Chernobyl. The 1986 nuclear disaster released a massive amount of radiation, turning a once vibrant area into a ghost town. The long-term effects, like cancer and birth defects, are a stark reminder of the dangers of nuclear power.
What I find really haunting about Chernobyl is how suddenly everything changed. One day a bustling community, the next an exclusion zone, abandoned, silent. The psychological impact of that is often overlooked.
It's true. We often focus on the science, the radiation, but the human cost, losing your home, your community, that's a whole other level of impact.
Absolutely, it's a cautionary tale about the lasting consequences of human actions, both on the environment and on ourselves.
All right, from a nuclear disaster zone to a different kind of deadly landscape. Up next, not one, but two death valleys to explore. First, Death Valley in the U.S., famous for its scorching heat and dry terrain. We're talking record-breaking temperatures here, the highest ever recorded on Earth, a mind-blowing 134.1 degrees Fahrenheit.
Yeah, Death Valley's extreme heat is a direct result of its geography. It's a deep, narrow valley nestled in the Mojave Desert, surrounded by mountains. It's like a giant bowl that traps hot air.
And with little vegetation to absorb that heat, it just intensifies.
Exactly. Plus, the air is clear and dry, letting sunlight reach the valley floor unimpeded. It all adds up to some seriously scorching temperatures.
It definitely lives up to its name. Now let's hop across the globe to the Valley of Death in Russia, located on the Kamchatka Peninsula. This valley isn't about heat, but something even more sinister: deadly volcanic gases.
Kamchatka is known for its volcanoes, and the Valley of Death sits right at the base of one, where cracks in the earth release this deadly cocktail of gases.
So it's not the heat that gets you, but the very air you breathe.
Exactly. You've got carbon dioxide, hydrogen sulfide, sulfur dioxide, gases that can kill you in minutes.
It's like something out of a sci-fi movie, an invisible wall of death. Speaking of places that send shivers down your spine, our next stop is Snake Island, also known as Ilha de Queimada Grande, off the coast of Brazil. The name says it all, a haven for snakes.
And not just any snakes, this island is packed with golden lancehead vipers, one of the most venomous snakes on Earth.
Yikes. What makes them so dangerous?
Their venom, it's a potent hemotoxin. Basically, it destroys blood cells and tissue. Even with antivenom, a bite can be fatal.
Oh, wow, that's terrifying. And I've heard there can be up to 5 snakes per square meter. Talk about a nightmare. You wouldn't catch me stepping foot on that island.
I think most people would agree. The Brazilian government has actually banned all visitors to Snake Island, partly to protect people and partly to protect the snakes themselves.
That makes sense. It's a unique species, and despite their fearsome reputation, they're actually endangered.
Exactly. It's a reminder that even the most dangerous places can be vital habitats for vulnerable species.
It's a fascinating paradox, a place uninhabitable for us, but crucial for the survival of another species. It highlights just how interconnected and diverse our planet is. All right, from the snake-infested shores of Snake Island, let's travel to the bone-dry landscapes of the Atacama Desert in Chile. This place is so dry, some parts are practically sterile, meaning there's almost no microbial life in the soil.
The Atacama is a classic example of a rain shadow desert. The Andes Mountains block moist air from reaching it.
So the mountains create a barrier, preventing rain clouds from reaching the desert.
Exactly. It's like the mountains cast a shadow, blocking the rain. And to give you some perspective, the Atacama gets about 0.04 inches of rain per year. That's 1,250 times less rain than New York City.
That's almost impossible to imagine. How can anything survive in an environment that dry?
While some life has adapted, there are plants that can absorb moisture from fog, insects that have evolved to minimize water loss, and even some microorganisms that thrive in the salt crusts that form on the desert floor.
Life finds a way, as they say. Speaking of unexpected, let's journey to a place that embodies the very definition of remoteness, Bouvet Island. Located in the South Atlantic, it's the most remote island in the world.
Bouvet Island is a volcanic island, almost entirely covered in glaciers. It's over 1,600 miles from the nearest landmass, which is South Africa. To put that in perspective, that's about the same distance as flying from New York to Denver.
Talk about isolation. It makes you wonder how anyone even discovered the place.
It was a French explorer, Jean-Baptiste Charles Bouvet de Lozier, back in 1739. But due to its remoteness and harsh conditions, it remained largely unvisited for centuries.
Can you imagine being stranded there? No shelter, freezing temperatures, and the nearest help thousands of miles away.
You know, the source mentions that empty lifeboats have been found on the shores of Bouvet Island, suggesting that some people haven't been so lucky.
That's a sobering thought. All right, before we move on, let's make a quick pit stop at Mount Everest. Technically, it's not permanently inhabited, but even surviving temporarily on Mount Everest is a feat of human endurance. The article highlights how just climbing it is a challenge, let alone living there.
Absolutely. The extreme altitude, thin air, and treacherous conditions make it one of the most dangerous environments on Earth.
What makes the altitude so challenging for humans?
As you go higher, air pressure drops, and so does the amount of oxygen available to breathe. At the summit of Everest, the air pressure is only about a third of what it is at sea level.
Wow, so every breath you take up there has way less oxygen.
Exactly, and that thin air, called hypoxia, makes it really hard for our bodies to function properly. You're also dealing with extreme cold, powerful winds, and a high risk of altitude sickness. It's a brutal combination.
It's incredible that people can even summit Everest, let alone spend any time up there. Okay, I know we've only just scratched the surface of this list, but to keep our deep dive from becoming a multi-day marathon, we'll briefly touch on a few more locations before we dive deeper in part 2.
Sounds good. Let's see, we've got the South Sandwich Islands, Round Island, Heard Island, the Dead Sea, Mount St. Helens.
Don't forget Cafacloban Island, Hans Island, the Great Salt Lake, Mount Washington.
Oh, right. And how about North Sentinel Island?
So many incredible places, each with its own unique story of uninhabitability. But for now, let's focus on 3 that stand out. Devon Island, Mount Washington, and North Sentinel Island. What's so special about Devon Island?
Devon Island, up in the Canadian Arctic archipelago, is so Mars-like that NASA uses it as a training ground for astronauts. The barren landscape, freezing temperatures, and isolation make it the perfect stand-in for the red planet.
It's a Martian training ground right here on Earth.
Okay,
what about Mount Washington? What makes it so uninhabitable?
Mount Washington, located in New Hampshire, is infamous for its extreme weather, particularly the insane wind speeds. It holds the record for the highest wind speed ever recorded on Earth, a mind-blowing 231 miles per hour.
I can't even imagine standing in wind that strong. I'd probably get swept off my feet.
There's actually a sign at the summit that warns visitors about the world's worst weather, and it's not an exaggeration. The combination of high winds, freezing temperatures, and unpredictable conditions make it a truly challenging environment.
Okay, last but not least, we have North Sentinel Island. What's the story there?
North Sentinel Island in the Bay of Bengal is home to the Sentinelese people, an uncontacted tribe that fiercely protects their isolation. They've consistently rejected any contact with the outside world, and any attempts at interaction have been met with hostility.
It really makes you think about the concept of uninhabitability. For the Thetnalese, the island is their home, their sanctuary. But for us, it's a place that's off limits, both out of respect for their wishes and for our own safety.
It's a powerful example of how uninhabitability can be a matter of choice, and how respecting those boundaries is crucial.
Okay, so we've covered a lot of ground in part one of our deep dive into the most uninhabitable places on Earth. We've journeyed from scorching deserts to frozen wastelands, from snake-infested islands to those remote and desolate corners of the world.
And we've only just begun. In part two, we'll delve even deeper into the science behind these extreme environments and explore the fascinating adaptations that allow life to persist, even when faced with seemingly impossible odds.
Stay tuned for part two of our exploration of Earth's most uninhabitable places. We'll be right back after a short break. Welcome back to our exploration of Earth's most extreme and uninhabitable places.
It's wild to think about all the forces that have shaped these crazy landscapes.
In part one, we did a quick tour of some seriously intense locations, from the scorching Guayaquil Depression to that snake-infested island, Isla de Quemada Grande. Now, I'm thinking we should shift gears and dig into the science a bit. Like, what makes these places so extreme?
I'm all for that. Let's get into the nitty-gritty of why these environments are the way they are.
Perfect. So let's revisit the Guayaquil Depression for a sec. It's known for its insane heat, those bubbling hot springs, and the poisonous gases. But what exactly causes all that?
Well, you've got to look at where it sits, right on the edge of three tectonic plates: the African, the Somali, and the Arabian. And these plates are slowly pulling apart, which stretches and thins the Earth's crust.
So, like, the ground is actually ripping apart there.
Yeah, pretty much. And that's what lets the magma rise closer to the surface. That fuels all the volcanic activity, heats the groundwater, and leads to those boiling hot springs and the release of gases like sulfur dioxide and chlorine.
Okay, that makes sense. But what about the extreme temperatures? I mean, it's a desert, sure, but over 113 degrees Fahrenheit is just brutal.
It's a few things combined. The low elevation means the air is denser, so it can hold more heat. Then, the lack of plants means there's nothing to absorb the sun's energy. And to top it off, the dry air doesn't have much moisture, so there's very little evaporative cooling going on.
It's wild how all those things come together to create that intensity. All right, let's go from the extreme heat of the Guayaquil Depression to the opposite end of the spectrum. The extreme cold and dryness of Antarctica and the North Pole. We touched on how cold air holds less moisture, but can you explain why those regions are so dry?
Imagine air like a sponge. Warm air is like a big, fluffy sponge that can soak up tons of moisture. But as it cools, that sponge shrinks and can't hold as much.
Right, right.
So when air masses travel from warm areas toward the poles, they get colder, right? And as they cool, they have to squeeze out some of that moisture, which falls as rain or snow. By the time those air masses reach the poles, they've been wrung out super dry.
So they're like dry sponges by the time they get there.
Exactly. Plus, those regions are so cold that any remaining moisture just freezes, making snowfall even less likely. It's this cycle. Cold creates dryness, and dryness makes it even colder.
Okay, that makes a lot of sense. Now let's switch gears to Chernobyl, a place where uninhabitability isn't natural, but a result of human actions. The 1986 disaster spewed tons of radioactive material into the environment, making the area uninhabitable for, well, who knows how long.
Yeah, Chernobyl is a tough one. What makes it so dangerous is the presence of radioactive isotopes like cesium-137 and strontium-90. These isotopes have super long half-lives, meaning they stay radioactive for a very long time.
So even though the disaster happened decades ago, the area is still highly contaminated.
Unfortunately, yes. And these isotopes emit ionizing radiation. That's the kind that can damage DNA and lead to all sorts of health problems, including cancer.
It's just hard to grasp the lasting impact of an event like that. Okay, let's go back to our two Death Valleys for a minute, starting with the scorching heat of Death Valley in the United States. You mentioned it holds the record for the hottest temperature ever recorded. What makes this valley such a heat trap?
It all comes down to the combo of its geography and the climate. It's deep, narrow, and sits in the Mojave Desert, surrounded by those tall mountain ranges. So basically, the valley floor acts like a giant solar oven, trapping hot air that flows down from the mountains.
And I'm guessing the lack of vegetation makes the heat even worse.
You got it.
Yeah.
Without plants to absorb the sun's energy and release moisture, the heat just builds and builds, leading to those crazy temperatures.
It's like a recipe for extreme heat.
Yeah.
Okay, now on to the other Death Valley over in Russia, where it's not heat, but those volcanic gases that are the threat.
Right, so the Valley of Death in Russia is on the Kamchatka Peninsula, known for its volcanic activity. The valley sits at the base of a volcano where cracks in the earth release a mix of toxic gases like carbon dioxide, hydrogen sulfide, and sulfur dioxide.
So it's not the landscape itself that's deadly, but the air. That's terrifying.
Exactly. In high concentrations, these gases can actually displace oxygen, which, we need to breathe. Plus, some of these gases, like hydrogen sulfide, are toxic even in small amounts.
It really shows you how danger can be hiding in unexpected places, even in the air we breathe. All right, time to slither over to Snake Island, or Iligi Queimada Grande, as it's officially known. We talked about those venomous golden lancehead vipers. Why are there so many snakes on this one tiny island?
Snake Island is a prime example of island biogeography in action. Thousands of years ago, rising sea levels cut the island off from mainland Brazil, trapping a population of snakes. And over time, with no natural predators to keep them in check, they just multiplied.
So they had this little paradise all to themselves and just went nuts.
Exactly. And isolated like that, they evolved in some unique ways. Their venom became incredibly potent, probably to quickly take down their prey, which are mainly birds.
It's amazing how evolution works. But wouldn't that lack of diversity be a problem for them eventually? Like, if they only have birds to eat, what happens if the birds disappear?
That's a good point. Island ecosystems are often delicate. A change in the bird population could have a huge impact on the snakes. It's a delicate balance.
It just shows you how interconnected life is, even in the most isolated places. Okay, from snakes, let's head to the bone-dry Atacama Desert. We talked about the rain shadow effect, but what else contributes to its extreme aridity?
Well, the location plays a big role. The Atacama is near the Tropic of Capricorn, which is known for having these descending air masses that are, as we talked about, super dry.
So it's a double whammy. Rain shadow plus those dry air masses.
Yep. And to dry things out even more, the cold Humboldt Current flows along the coast of Chile. That cools the air even further, making it even harder for it to hold moisture.
So rain shadow, dry air, and a cold ocean current. It's no surprise it's one of the driest places on Earth.
It's all about how geography and climate work together to create these extreme environments.
It really is. Okay, let's jump from the driest desert to the most remote island in the world, Bouvet Island. What makes it so isolated?
It's all about location. Bouvet Island sits way out in the Southern Ocean, far from any major landmasses. It's smack dab on the mid-Atlantic ridge, a volcanically active zone where tectonic plates are spreading apart.
So basically, it's a volcanic island in the middle of nowhere.
You got it. And that remoteness, plus the brutal weather and lack of resources, make it a really tough place for anything to survive.
And yet, I bet there's some life that manages to cling on, right?
You'd be surprised. Scientists have found lichens, mosses, and even a few insects on the island. These tough little guys have adapted to survive the extreme cold, crazy winds, and limited sunlight.
Life is just incredible. Okay, before we move on, let's swing back to Mount Everest and why its extreme altitude makes it so difficult for humans to survive.
So as we go higher, the air pressure drops. And with it, the amount of oxygen we can breathe decreases. This thin air, which we call hypoxia, makes it really hard for our bodies to function.
So it's not just the cold and wind that make Everest so dangerous.
Right. At Everest summit, the air pressure is only about 1/3 of what it is at sea level, meaning every breath you take has only 1/3 of the oxygen you're used to.
Wow, that's wild. It's amazing that climbers can even get to the summit, let alone survive up there for any amount of time. Okay, let's do a quick recap of those other three crazy spots. Devon Island, the one that's so Mars-like that NASA uses it for training.
Oh yeah, Devon Island is like a Martian playground. The landscape is barren, it's freezing, and even the day-night cycle is similar to Mars.
So it's basically a Martian training camp right here on Earth.
Okay, remind me about Mount Washington again.
Mount Washington is infamous for its insane weather, especially the wind speeds. It holds the record, 231 miles per hour, fastest wind gust ever recorded on Earth.
I wouldn't want to be caught in that. No wonder they say it's uninhabitable.
And finally, there's North Sentinel Island, home to the Sentinelese people. They're that uncontacted tribe that's fiercely protective of their isolation.
It really makes you think about how uninhabitability can be a matter of choice, and that Respecting those boundaries is so important.
It really does.
Well, I think we've covered a ton of ground here in part 2 of our deep dive. We really have. We've gone from deserts to islands and even touched on the impact of human actions on the environment.
And we've only just begun. In part 3, we're going to explore some of the bigger implications of these uninhabitable places. Like, what's their scientific value? And how do they help us understand life on Earth and even beyond?
It's going to be fascinating to see how these seemingly desolate places contribute to our knowledge of the world.
So make sure you join us for part 3 to wrap up our exploration of Earth's most uninhabitable places. We'll be right back after a quick break. All right, welcome back to our final exploration of Earth's most uninhabitable places.
We've really covered some ground, haven't we? From scorching heat to frigid cold, toxic gases, and even a whole island crawling with venomous snakes.
It's been quite the adventure. We've delved into the science behind what makes these places so extreme, but now I'm curious about the bigger picture.
Yeah, what's the takeaway? Why should we care about these seemingly desolate corners of the planet? What can we learn from them?
Exactly. They seem so far removed from our everyday lives. So what's their significance?
Well, they're definitely more than just curiosities. These uninhabitable places can actually offer us some really valuable scientific insights. They challenge our understanding of life itself and even raise important questions about our relationship with nature.
Okay, now I'm intrigued. What kind of scientific insights are we talking about? Can you give us some examples?
Sure. Think about the Atacama Desert. Its extreme dryness, high altitude, and clear skies actually make it one of the best places in the world for astronomical observations.
So like a natural observatory?
Exactly. Astronomers can study distant galaxies, observe the birth and death of stars, and even search for exoplanets with amazing clarity from the Atacama. And it's not just astronomy. Scientists are also studying the unique life that thrives in the Atacama's harsh conditions. We call those extremophiles.
Right, those are the microscopic organisms that can survive in extreme environments, like the super dry, salty, and even toxic conditions you find in the Atacama.
Exactly. Studying extremophiles helps us understand the limits of life, and it might even provide clues about the potential for life on other planets.
That's pretty amazing. So by studying these uninhabitable places, we're not just learning about Earth, we're potentially learning about life in the universe.
You got it. These extreme environments offer unique opportunities to explore big questions about the universe and our place in it. It's pretty mind-blowing stuff.
I'm starting to see how valuable these places are.
Yeah.
You also mentioned that they challenge our understanding of life itself. What did you mean by that?
Well, for a long time, we thought life needed very specific conditions to exist. Liquid water, moderate temperatures, a source of energy like sunlight, the basics. But then we discovered extremophiles.
Right, those organisms that can survive in those crazy conditions we've been talking about.
Yep. Extremophiles have completely changed how we think about life. They can survive in boiling hot springs, frozen glaciers, acidic mine drainages, even deep underground where there's no sunlight or oxygen.
It's hard to wrap your head around sometimes. It really opens up the possibilities for where life might exist, even beyond Earth.
It really does. It shows us just how resilient and adaptable life can be.
So we've covered the scientific value of these places and how they've changed our understanding of life. What other lessons can we learn from these extreme environments?
I think they also highlight how interconnected our planet really is. When you look at a place like the Atacama Desert and you see how the mountains, the ocean currents, and the global air circulation all work together to create that extreme dryness.
It really emphasizes that everything is connected, right?
Exactly. These uninhabitable places show us the delicate balance that sustains life on Earth. And they underscore how important it is to protect our planet's ecosystems, even those that seem remote and desolate.
It's a good point. It's easy to forget about that interconnectedness when we're focused on our own little corner of the world.
But these extreme environments are a stark reminder that what happens in one part of the world can have ripple effects across the globe.
So in a way, these uninhabitable places are helping us understand and appreciate our own habitable world even more.
Absolutely. They give us context, perspective, and a deeper appreciation for this incredible planet we call home.
Well, I think that's a great note to wrap things up on. We've explored some of the most extreme environments on Earth, delved into the science behind their extremes, and discovered how these seemingly desolate places actually provide valuable insights into the nature of life and the interconnectedness of our planet.
It's been an incredible journey, exploring the boundaries of our world. I hope it encourages everyone listening to keep exploring and stay curious about our amazing planet.
Thanks for joining us on this deep dive into Earth's most uninhabitable places. We'll see you on our next adventure.